3.4, we're going to talk about basic strategies in order to solve our exponential and logarithmic equations. So here I have 2x, and basically it's going to be switching from one form to another is going to be the biggest thing. 2 to the x equals 32. If I rewrite this, I could say 2 to the x is 2 to the 5th power, because I know that 2 to the 5th is 32. So if my bases are the same or equal, then so must be my exponents. And the property that we would use for that is 1.1. It looks like this property should be over in that box, because that's what it's asking you. How do you rewrite it? What's the solution, and what property did you use? For natural log of x, subtract the natural log of 3. We would set them equal to one another by adding the natural log of 3 over. And if we have natural log of natural log, again, if the natural logs are the same, then the parts must be, and that's called a 1-to-1. Alright, so here we have 1/3 to the x is 9. We can rewrite that as 3 to the negative x, because if I reciprocate, I get a negative exponent. And 9 we know is 3 squared. So negative x is 2, therefore x is negative 2. Again, we have a 1-to-1 property. If the bases are alike, so are the exponents. E to the x is 7. Well, I can take, because e is a natural number, I can take the natural log of both sides. The natural log of e to the x and the natural log of 7. Because this is the base and the base are alike, we're going to get x is the natural log of 7. And that's our inverse property. Here I can switch from log form to exponential form. So e to the negative 3 is x. And that's just changing from one form to another, which is our inverse property. And you could punch this in the calculator and actually come up with a number. And the same thing with f. 10 is the base, so it can kick up. Therefore, x is 1/10. And that's our, again, our inverse of our exponent rules. This is the inverse of our exponent and log components. So just ways to be able to solve in the steps to do it. Something that we should be a little comfortable with. On page 2, we're just going to go through some solving and how to solve for x. So if I have e to the x is 72, I can take the natural log of both sides. So that's going to cancel out because the base and the base are the same. So x is the natural log of 72, which you can use your calculator to 3 decimal places. In order to get to the x, I first have to divide. So 2 to the x is 14. If I change this right now as an exponent as it stands, 14 is not a base of 2, so I can't do that. I would need to change it to a log form. Log base 2 of 14 is x. I still can't do it because my calculator is not in base of 2. So I would change it to the change of base or calculator ready form. Log of 14 divided by log of 2, and then use my calculator. 4e to the 2x, first thing I got to do is I got to divide by 4. So e to the 2x is 5/4. Now when I take the natural log of both sides, that's going to cancel, leaving 2x. And then divide by the 2. So be careful when you punch this in the calculator, because it's going to be natural log of 5/4. You're going to want to use parentheses and then divide by 2. Make sure you use everything appropriately, because otherwise it's going to do the natural log of 5 divided by 4, or it's not going to do the right order of operations. So make sure when you punch it in you're using parentheses appropriately, and you should get 0.112. All right, on page 3, that 2t minus 5 is actually an exponent down here. So in order to get to the exponent, we first have to get rid of the constant that's here. So we're going to have 2, and then that parenthesis, add the 4 over. Then we're going to divide by the 2. So I'm going to have 3 to the 2t minus 5 is equal to 15 halves. All right. It's an exponent. I have to get to my exponent. And the number one thing you're going to find when you're solving is that if you have exponents, you're going to change them to logs. And when we have logs, we're going to change them to exponents. So we're going to change this. We're going to change it to log base 3 of 15 halves is 2t minus 5. Now I get to solve for my t. So this log base 3 of 15 halves is going to add 5, and then whatever we get for that answer, we're going to divide by the 2. So when you put this all in your calculator, again, watch your parentheses, watch how you're inputting everything, check it, but you should get 3.417. So it's a matter of, do you know your order of operations and can you punch it in the calculator correctly? So the key part here is actually this transformation from an exponent to a log. Then the solving methods are your normal solving steps. All right, here we're going to factor this because it is kind of a quadratic because it has an e to the 2x. And the way you can kind of simplify it out is if you saw e to the x, it's squared. So then I have 3 e to the x. So that kind of helps if you put that e to the x out, you can kind of see that it is a square. Now when you factor this, e to the x squared can only be ex. What multiplies by 2 and adds to be negative 3? Well, that's negative 2 and negative 1. So e to the x is 2 and e to the x is 1. When we take the natural log of both sides, natural log of e to the x and the natural log of 2 goes away, so x is the natural log of 2, which is 0.6931. And when I do the natural log e to the x is natural log of 1, goes away, we get x is the natural log of 1, which is 0. So we actually get those two solutions. So what this says down here with logs, because we're going to practice some of them, is now we're going to change them to exponents. When we had exponents, we changed them to logs. And now that we're going to practice some logs, we're going to change them to exponents. So in this case, natural log of x is 2. It starts with a log. I know what my base is. It's base e. So x is e squared. And you can punch that in your calculator to a couple 3 decimal places. This is not an exponent. It's a typo. This is actually a base. Log base 3 of this. Log base 3 of that. If the log bases are the same, then so are the pieces. So 5x minus 1 must be x minus 7. So 4x is negative 6. Or how about positive 7, because I can put that in there. So that gives me positive 8. So x is 2. One thing I do need to do is I must check to make sure there's no negative if I check it. So if I put in 2 in here, I get a positive, and that's all I care about. If I put a 2 in, I get a positive, and I'm good. So that works. All right, I need to isolate my natural log, so I'm going to subtract the 1. I'm going to divide the 2. And then I'm going to convert it from log form to exponential form. E to the negative 1/2 must equal x. You can punch that in your calculator and get 0.6065. Alright, first thing you gotta do is get rid of the coefficient. So log, and sorry, that's a base 5 again. That's a typo. Divide by 2, so log base 5 of 3x is 2. Now in order to get to that piece, I'm going to have to change the log to exponential form. The base kicks up. 5 squared is 3x. 25 is 3x. So x is 25/3. This next page is the focus of make sure things work. This is what I was talking about on the last page. You have to check it to make sure that there are no negatives. So more than likely one of these is going to come out that we're going to end up rejecting. So here I have a plus sign. If I have a plus sign, it means I have a multiplication by our definition, by our rules. If I have a coefficient, I also have an exponent. So now, if my natural logs are the same, then so are the pieces. So I'm going to get x squared 2x squared, sorry, 2x squared minus 3x minus 4x plus 6 is the same as x squared. Therefore, x squared minus 7x plus 6 is 0. So x minus 6, x minus 1. So x is 6 or 1. I do need to put them back in, and I do need to check it. If I check, I'm going to get 6 minus the 2, which is okay, and 2 times 6 minus 3 is okay. If I put in the 1, I get 1 minus 2, and that's not going to be okay, because I'm putting them in here. I can't have negatives, so the 1 we're going to reject, and x equals 6 is the only one that's going to work. So here's some study tips. Again, how to solve. We isolate. We change logs to exponents, exponents to logs. You can read through that. All right, when we're going to approximate using a calculator, we're first going to write the equation equal to 0, and then we're going to graph it. Because in order to put it in our calculator, we have to have it y equals, because solutions are x-intercepts. That means the y has to be 0. So 0 is x squared minus x minus 2. Put it in the proper order, please. Oops, I'm sorry, that's a natural log. So x squared, it's going to be x squared minus the natural log of x minus 2 equal to 0. And you can type that straight into your calculator as it is. X squared minus the natural log of x minus 2. Make sure to close your parenthesis, otherwise you're going to get an error there. Oh, let's set it back to a normal 10 by 10 window. And we do see, if I wanted to kind of zoom in here so I could see things just a little bit clearer perhaps, because I am interested in the solutions, and solutions are x-intercepts. I do see that I get 2 of them, and it's a matter of second calculate, 0, option 2. Make sure your spider is left, make sure it is right, hit enter. and one of them I find is 1.564. And then you're going to repeat the process for this other side, and you should find the other side to be about 0.138. But that's just using your calculator, how to approximate and guess and estimate, of which we've been doing several times over. All right, the last example we have here is we're going to double an investment of $500 at 6.75% compound continuously. There's that word continuously again that we've seen in the past, which means we're using the E formula. So if I'm going to double it, my final solution is 1,000. My initial is 500 because that's what we started with. E, we know our rate of 0.0675. You got to change it to a decimal, but it says how long, so that means we don't know what T is. So I have my substitutions in, but I do need to solve this, and I'm going to get divide by 500, so 2. Once I have it into simplified into exponential form, I do need to change it to log form, so I can take the natural log of both sides, and when I take the natural log of E, it just leaves the exponent. Divide by that, so my time is the natural log of 2 divided by 0.0675. And that you can punch in your calculator, and you're going to find your time to be about 10.27 years. We can pick some points and plug this into our calculator. Because we know at 0 it was 500, and then we know at 10 years, so let's see, I think that the time here should be 2, 4, 6, I mean it goes by ones, but I'm just listing out, and at 10 it was up to a little over 10 is when it got to 1,000, so about there. So we know our picture looks something like that, is the increase that it went at. All right, so that concludes 3.4.